My name is Erik Axelsson.
And I'm Max Witt, and you're welcome to the Git tutorial. We will show you the basic crash course of Git, the first version control system, and also how you work with Git in collaboration with GitHub and your team members. First of all, we have some information about those who do the DAT 255 course. First of all, there's a course page on GitHub which you should check if you haven't. There's also a link to this presentation if you like. And for those of you who haven't found any groups or group members yet, please do so. And
if you don't, email that email address.
Well, actually tonight, then you might be in trouble. So please do. Welcome.
Thank you.
Yeah. We're going to talk about the most part about around Git. You can help to next, I believe.
Yes.
The agenda.
I'm very sorry about the slideshow. It's screwed up because it's Microsoft. This is what we're going to do today. Why we are here, what is Git, and how are we supposed to work with it, and how does it work really. Git introduces a bunch of objects and items which we will present, and also a few verbs and actions which you use every day to manipulate the system and manipulate your work in coordination with the system. We will also talk about collaboration, which means working together in a team, closely with GitHub. Also some practical guidelines which are sprinkled everywhere in the presentation, so watch out. And if there's time, we will do something about Git flow.
What we're not going to talk about is the different graphical interface for Git, because we're only going to focus from the terminal today. We would say the most tools use the standard syntax, so the same for the most different GUI.
Actually, everything we do here today is universal for Windows, Mac, and Linux, and when you use a terminal, you actually know what you're doing, in contrast to using a GUI. First of all, why are we here?
First off, version control isn't a backup like Dropbox or Google Drive or something like that. I don't recommend to use that for code. It's like using Word as an IDE. It works. You can compile code in it, but it's just stupid to do.
Actually, most of those services, Google Drive and Dropbox, use version control underneath the hood for their own sake. They do their own versioning, and you can actually check out previous versions of Dropbox files if you like, but that's not the main purpose of that particular service. What we actually want to do is something more specific. Version control systems are built for creating versions at your leisure, not when the system tells you to. Backup systems like Google Drive use either time-based versioning or delta versioning. Like, for example, if you change a file in Dropbox, it backs it up automatically without even knowing what the change was. And that's not what we do. We're supposed to save what we mean and not just because anything happens. And these systems, version control systems like Git, Subversion, CVS, ClearCase, and a lot of them, allows you to do this stuff when you feel like creating a version. And that's actually what we're supposed to do. If you use Google Drive, for example, for coding, let's say that you implement Google Drive in Eclipse or something. It has actually been done. Then you might set yourself in a position where you're ready to try and compile your code, but your friend is still updating and he's writing some stupid stuff which may destroy your compile time or runtime. depending on what you did. So we actually want to have our own version of the code, and at certain points kind of sync it with what's on the server and what your friend sees. So the real purpose of not using Dropbox or Google Drive is to keep track of what you mean, actually, and not just keeping track of the changes.
What you should use Git for is first and foremost the code. Regular text files with code in it is the main purpose of it, but it can also be used in static stuff like image. That you say you have one image and you add it once, and that's also very good for. What it's not good for is generating generated files. Say class files in Java that change every time that you compile the code. That shouldn't be used for. Or different, every generated file,
Yes.
whatever.
Actually, Git works its best ways while using text files and can detect differences within a text file on a per line basis, which means if you do a change in a file and your friend does a change in the same file, as long as you're not changing the same line or row, you should be fine. It should stitch together just as anything. If you change a binary file, Git will consider the whole file as changed, even if just one little number is changed somewhere. So
and then the whole file will be saved again. So the file will have two different files in your repository.
Yes, it will increase the file size dramatically. So if you have resources like images, change them with respect to the file size you might have left. In your case, it won't matter because your project might reach about 20 megabytes or something, and I think GitHub allows about 500 megabytes per project or something. So that's okay. Next up.
What different objects we have? First off, we're going to explain a little about the repository. The repository is a the thing that you just have. It's saved in the .git file in your project folder. It contains a lot of different things. Commits is one. We're going to discuss this later on.
It actually concerns all objects which are related to the project and nothing outside it. So it kind of sets the bounds of the project and the realm of where you might use your version control system.
You can see it like a database that everything your whole project is saved in.
Yes.
You can't really see into it more than use the git commands, but it's all is saved in it.
Yes. And now I'm going to draw a bit. We're going to talk about the commit, which is the most central part while using version control systems. It's the most essential object because in a commit, every change is tracked. We track every change since the last commit, which means they work recursively since from the beginning of time and forward. I like to draw commits like circles. That's a commit, and it contains the actual changes in code, as well as a tag of the ID of the username, the name of the commit as an ID, which is more or less unique, and also a message. The message is very important because it should describe what the commit contains. The message is always written by the developer or the user, and should never be auto-generated or copied or something. It should really be specific to the changes made in that particular commit. That's very important. Commits build on each other. which means that a new commit has an ancestor. So all the changes recorded in this commit are recorded in relation to the changes that were recorded in that commit. So if we have a state of the system in that commit, we can see that as the base when we create the next commit. And let's see. A commit may track changes made to one specific file or many files as you choose. And exactly how we do that, we're going to talk about that later.
Yeah, I commit, if you don't say it, we have a unique ID always. And the message should be about one sentence, not more than that. It shouldn't be hard to read the whole, just one small thing, and that's the only thing in that commit.
Yes. Actually, as the message is supposed to present what's in the commit, and also have specific rules like it's not supposed to be more than one sentence long, that means that the changes made in the commit must not be anything more than just that one sentence. So if you do 2 changes, you're supposed to make 2 commits of it. Do you get it? Right.
And why do you believe it's like that? It's because when you figure out maybe 10 months from now that damn, that commit, that was really stupid. It's I need to remove that again. Then you can just go back in the Git log and take that node and just remove it and rebuild the tree.
Yeah, in a way, if we had that, we'll kind of rewrite the history in some way. And if there are more changes than just the one thing that we want to get rid of, we will have side effects which will then make even more problems appear. So, one change, one commit, and please describe what you do very carefully so that you can read it.
Yeah,
Beautiful
next.
Yes. Labels.
Yeah, labels is a more high level way of thinking. The label is the unique ID for every commit. It's also the name of a branch. We're going to explain branch and tags more soon. But it's you can use a label pretty much where you want to point to anything.
Yeah, you can see the label as a link to something else, most often a commit. Branches are special kinds of labels that always point to the latest commit in a development timeline. You can think of it as a timeline, but actually it's just a link, a pointer that points at a commit. And we have other kinds of labels like tags. Tags are specific in a way that they point to a specific commit and not the latest one in a line. And we'll always point at that commit as long as the tag exists. And also, we have some special labels like head, for example, which will jump around and point at whatever's at the head at the moment where I am. Branches are very useful because it's hard to refer to commits through their IDs. It's possible, but it's very hard to remember them. And so branches are there to make sure that we can keep track of the different development lines. If we have one specific feature which is not concerning everything else that's being developed, we have that in a specific branch. And then at some point we take that development line and shove it into the master branch. The master branch is a special branch which is always present and is mostly considered like the golden truth about the project. It should always contain working code and shippable stuff in a way. Let's see. Yeah.
There also exist artifacts like the workspace. The workspace is what you see in your IDE. It's what you see in your file system when you're browsing around in it. it's very used for the moment. That isn't real. When you use Git, that isn't stationary. It can change.
It will change.
Oh, yeah.
Definitely. Actually, every time you perform some kind of change in Git, the workspace is kind of replaced and removed and replaced, and you might wipe the whole workspace and replace it with something completely different, and then go back. And we use these commits that are recorded into the repository to recreate the workspace every time. So nothing is really holy in workspace except for the Git folder. If you have changed something and that breaks, you can always go back to whatever the last commit was. So make sure that you make commits just like a climber hammers and spikes into the rock at close intervals, which means that if he falls down, it doesn't fall too long, right? And that also follows the idea of only recording one change per commit. If you do more stuff and you break something and you have to go back, you will lose very much. Anyway. Some version control systems, like Subversion, for example, considers every change in the workspace as something that you want to commit immediately. Git tracks this the other way. You may see changes in the workspace with a special command we will show later, and nothing of that will be committed until you add it to the staging area. So we kind of have the workspace is as your folder where you work. The IDE does some kind of changes, and here are files, like whatever. And then we have some kind of staging area where you pack everything. I choose to, if I have made changes to these 3 files, I choose to stage this file. And out of what's staged in the staging area, I create a commit, real commit, which has some ancestor. And the idea behind this is that you might make several changes in a leap, and you may perform several commits at once without having to revert your workspace. You just choose what you want to commit for that specific commit. And that's the workspace and the staging area. We consider the workspace clean when it matches the state of the last commit, or the commit that we checked out. And it's dirty whenever some file is modified. Actually, it's just dirty when a tracked file is modified. Every file is considered untracked until it's added to the version control system. And
then Git will not change it whatsoever.
We will show this later as well. You'll see that when we come to the actions part. I think that's not right.
Question that far. It's a lot of theory. After this small rest, we're going to have talk about how we do it in practice.
Yes, and we will show some examples. Actually, the whole idea about you being here today and is to ask questions, actually, because we could have done this video cast thing online just for everyone to watch, but please take your time and ask questions, because this might be helpful not just for you but also for your friends. Okay? So anything, please. Right? We'll go through one more thing before we start with the theory, and that's the gitignore file. This is a special file that we create. It contains text about what files in the project are not supposed to be tracked or at all shown in Git. It's useful for excluding class files and generated files, like we talked about before. And
in GitHub, it's when you create a new repo, you can change Java in that ignore list. I recommend using that.
Yes. There's also a specific Android gitignore file, which also includes generated Java files which may appear. And those are predefined files that you may download to your project from GitHub for free. That's nice. But you should take some time and figure out what actually happens when you modify the gitignore file, because it's quite neat, and yeah, you get a lot of understanding about how the system works through this. And we'll have an example about that later. It works with paths and directories, which means I can tell the gitignore file that a specific directory and its subdirectories is supposed to be ignored. Also, any files that have the .class file name or file extension or something. Works with wildcards and regular expressions, if you know that. It's quite powerful, actually.
And what we missed to say is name is git ignore, because the file name should be is git
Yes.
ignore. It's a file name on the file.
In the file system, yeah.
Yeah.